Okay, hello. There was some homework that was due kind of a long time ago, I think. And it was, I don't know, I guess last week or something like that. And it was page 5, number 9 from the Foerster Conics Packet. We're about to hand this in. So let's go over this because we didn't go over any of these problems in class. And I actually think they're kind of, I don't want to say hard, but they're harder than the problems that we had been doing. And all of them involve some certain level of thinking, understanding, drawing pictures, understanding all the relationships between all the various parts of the conic section. So, okay, let's go. Hyperbola with foci at -3, 1 and -3, 5. -3, 1 and -3, -5. Okay, we can do this. That's -3, 1 and -3, 2, 3, 4, 5, -3, -5. Okay, those are the foci. Well, sort of immediately I can find the midpoint of those 2 points, and that would be -3, -2. So, boom, right there, -3, -2 is the center. Hyperbola with foci, and also C is 3, so that's a nice thing to know. Okay, I already kind of got this under control. I have one more piece of information. Asymptotes with slopes that are plus or minus 3/2. Okay, so here we need to be a little bit smart. We need to recognize that this is a vertical hyperbola, whose because the foci are vertically aligned with each other. And all right, the center is -3, 2. So I don't know what the happy box is, but I do know the slopes of the asymptotes. I guess I should write that down. The slopes of the asymptotes are plus or minus 3/2. Okay, and so what does that kind of mean? It's kind of, how much you have to go up and how much you have to go over to get a diagonal of the happy box. And so, okay, I guess I could just even draw this in, right? Because this is kind of up, this is up 3. Well, I don't want to draw this because it's a little bit misleading or whatever. But here's what I know and here's what I don't know. I know what the foci are. I know how far apart the foci are. I know C is 3. I know the center is -3, -2. But I don't know what A and B are, and I also don't know, well, I don't know what A and B are, so I don't know where the vertices are. But the vertices are going to be somewhere in between, one vertex is going to be in between -3, -2, and -3, 1. So I know I sort of need to go up to the vertex, that would be A, and then over to the corner of the happy box, that would be B. And so, okay, what I'm really trying to say here is that in a vertical hyperbola, you go up A and over B. That's really it. So you have to be sort of experienced enough and comfortable enough with hyperbolas, both horizontal and vertical, to realize this fact. I guess maybe a simpler way to put it would be the following: that I just kind of know. Let's just draw 2 sort of generic hyperbolas with 2 generic happy boxes, and in one case, yeah, this is I think the best way of talking about this. So yeah, so this is a vertical hyperbola down here. This is a horizontal hyperbola down here. I think I've said all this before, but perhaps never quite so explicitly. If I'm going to draw this generic horizontal hyperbola like this, and this generic vertical hyperbola like this, then okay, built in to what we're doing is that this is A and this is B, and built into what we're doing here is that this is A and that's B. This kind of this segment here is B. Okay, and so because that's just what A is, it's the distance from the center to a vertex, and b is the direction in which the hyperbola is being stretched out, the factor by which the hyperbola is being stretched out in the direction that is that's perpendicular to the transverse axis. Okay, the point of all of this is, you could almost like memorize this or something and put it on a note card. What is the slope of the asymptotes for a horizontal hyperbola? Answer, it's going to be b over a. And you may have even memorized that formula or something, and you may have memorized it incorrectly, because for a vertical hyperbola, the slope is going to be a over b. And that's because a and b have switched places, but of course we still describe the slope in the same way as you know, rise over run, how much you go up a high pitch, you have to go over. Alright, this was an extremely long-winded way of saying that this is the fact that you have to extract from this problem in part A, that 3/2 is a over b. Okay, and this is one of the most difficult problems on this page, perhaps, because what now? Well, do I have enough information to find a and b? I do, because I also know that a squared plus b squared equals c squared for a hyperbola. And so since a squared plus b squared equals c squared, we know c in this case is 6. And so what we really have now is a system of equations. No, c is 3 rather. So since c is 3, this is 9. And also a over b is 3/2. And so the way to solve this problem, the only way I think to solve this problem, is by solving this system of equations. I'm given c effectively, so I have one relationship between a and b, the Pythagorean relationship between a, b, and c, and I have the slopes and the asymptotes, so I have another relationship between a and b. We did a problem exactly like this on the Hyperbola packet, so it was on the video that I made just before break, but okay, you know, whatever. Let's just solve this problem really fast and be done with this. So what do we get? We get that a is 3/2 b. And if a is 3/2 b, then let me just stick it in and use a substitution. So 3/2 b quantity squared is, plus b squared is 9. And now I just have a simple quadratic equation, or it's not even quadratic hardly, a simple equation in one variable. So I get 9/4 b squared plus b squared is 9, so that's 13/4 b squared is 9, and that's a little bit of a surprising answer, but anyway, b squared is therefore 36 over 13. And if I believe my math there, then that is the answer. This is kind of ringing a bell a little bit. I'm going to check this in a second. Maybe I should just check it now. Or maybe I should just have confidence in myself that I'm doing this problem right. Ha 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 ha. Man. Lost my book. Well, never mind. I suppose that's just right. Found my book. Sorry for the dead time. Let's just, I think it is kind of worth looking this up, because that's kind of a weird answer. A little bit. Hyperbola with foci, this is number 33 from section 13.3. And yeah. Ba, ba, ba. Oh my god. Number 33. Oh, why are you doing this to me? Well, that's pretty annoying. I can't believe that they did that. Okay, whatever. I think this is just the right answer. So I bet it is. I can double check my work, but I think I don't need to, because, yeah, there it is. A really is 3/2 b, so a squared really is 9/4 b squared. 9/4 and 4/4 is 13/4, so there's just no way we could have gone wrong. Okay, good. If that's b squared, then what is a squared? Well, if that's, what's the best way to do this? Well, to get a, I should multiply b by 3/2. So maybe the simplest thing to do here is actually say that if a is 3/2 b, then a squared is just 9/4 b squared. And so, because I really only need a squared for the formula, so what's a squared going to be? It's going to be 9/4 times this gross number, and that will give me 81/13. That was a little bit of a smooth way of doing this. All right, so what does that tell me? It tells me, well, something I kind of already knew maybe. The hyperbola is going to be roughly looking like this. And not wasting time drawing the happy box accurately or anything because the numbers are gross, let's just write the equation, which is after all you had to do for this problem. And the answer is going to be, well, it's a vertical hyperbola, so that's -3, -2, so y plus 2 squared minus x plus 3 squared equals 1, jump, jump. And the y coordinate has been stretched out by a factor of a, so down here we'll go a squared, so that's 81/13, and down here is 36/13. So I think this is right, and I think this is a pretty hard problem, and I'm glad that I'm making this video because you probably thought you were wrong or something when you got this answer, but I think it's actually correct, and I'll be very sad if it isn't. Let's push on. Yeah. Whew. I did look up this problem in the back of the book, but they, instead of giving this as the answer, they multiplied the entire thing out and gave the answer in a completely unhelpful form. So, normally I would be going over this in class and I would rely on someone in the room to be like, yeah, that's what I got too, but oh well. B. Hopefully these next couple ones are a little bit easier. B. Conic with center at 4/7, one vertex at 21/7, and eccentricity 15/17. Okay, 21/7. Yikes. So 21/7 is something, and there's another thing at 4/7. So 4/7. What is at 4/7? A center. So this is a center, and this is a focus. Okay, well that's a little bit, no, sorry, a vertex. It's a vertex here at 21/7. Okay, well this is actually kind of nice because if I know the center and I know a vertex, then I can immediately subtract, and I can get that A is 17, because that's just what A is. This is just between the center and a vertex. Yeah. 4/7, 21/7. Yikes. Okay, the eccentricity is 15/17. Alright, well if the eccentricity is 15/17, first of all, I note that this is an ellipse, because the eccentricity is less than 1. But also, as we've known for a long time, eccentricity is C over A. And, okay, so what I know is that, C over A is 17 has to be 15/17. So the only way for that to be true is if C is in fact just 15. So I do know that C is 15, and that means that I'll have over here at 19,7 will be my focus, one of my foci. And okay, this is going to be like a very elliptical ellipse. The answer is it's going to kind of look something like, something like that or whatever. And yeah, if A is 17 and C is 15, then what's B? Well, B then has to just be 8. Because it's just true that 8, 15, 17 is a Pythagorean triple. That's a well-known Pythagorean triple. Well, that's it then. I'm done. Because I know that this is an ellipse. It is horizontal, so it's like x minus 4 squared plus y minus 7 squared. And x is being stretched out by a factor of 15, so that's 225. And, no, x is being stretched out by a factor of 17, So that's 17 squared, 289, and the y coordinate is being stretched out by a factor of 8. So I'm very confident that that is the right answer there. Good, 2 down, bunch to go. C, conic with foci at -3, 8 and -3, -4, -3, -3. Okay. Cha-cha, cha-cha. So boom, boom, boom. So up here at -3, 8 is something. What is there? It's a focus. And -3, -4 is another focus. So great. Well, if those are the foci, of course, I can immediately take their average. And that's going to be 2, the average of the y-coordinates. So I have the center at -3, 2. And so this, okay, so maybe I'll even just write that, center, -3, 2. And also, what were those points again? They were the foci. That means C is 6. And my last piece of information is that the eccentricity is 6/5. Okay, well, if the eccentricity is 6/5, then that's greater than 1, so this must be a hyperbola. So that's worth mentioning. But even easier, the eccentricity is just C over A, and I already know that C is 6, so it's 6 over A, and so the conclusion is that A is just 5. So this is actually almost exactly like the previous problem. And there it is, right? If A is 5 and C is 6, then you can do the Pythagorean Theorem. A squared plus B squared equals C squared in a hyperbola. So what is B squared? It's 36 minus 25, so it's 11. And yeah, is it worth drawing out this hyperbola accurately? Maybe not. The vertices are 5 away from the center, so 1 unit closer to the center than the foci are. And the hyperbola, sometimes it's nice to just kind of half sketch it a little bit, so we at least get that it looks like this. A is 5, C is 6, it's a hyperbola, center -3, 2, so I'm ready to just write down the answer now. It's a vertical hyperbola, -3, 2, so the y-coordinate has been shifted by 2, and the x-coordinate is shifted by 3, so x plus 3, and the y-coordinate has been stretched by a factor of 5, so it's 25, and this we determined is 11. So that's the answer for part C. Okay, 3 down, 5 to go. I like these because they're more fun than some of the other parts of this unit because it's all thinking. There isn't a lot of totally tedious algebra. It's a lot of actually kind of understanding and drawing pictures. So I think it's a good intellectual kind of activity. Relatively speaking. Okay. Woo! Good. Part D. Okay. Well, what does part D say? Conic. Center at 1, 2. Alright. So 1, 2 is my center. Great. Directrix x equals 7. 2, 3, 4, 5, 6, 7. So here is my directrix, and corresponding focus at 3, 2. Okay, it's actually sort of interesting that they gave you all this information, because it's actually more information than I even need, right? Directrix x equals 7, focus 3, 2. If you had only told me that this was the center, this was the focus, if you had only given me the focus and the directrix, that's actually sufficient for me to completely determine what the conic is. But by giving you the center, I guess they make it kind of even easier because, well, okay, maybe that's misleading to write C and F there. Let's just keep it in our brains. Center and focus. No, I take it back. It wouldn't be enough to just give you the the focus and directrix. You'd have to give me the focus, the directrix, and the eccentricity. So I retract that previous statement. So here, I am being given the focus. Maybe I'll write it in like blue or something above. Right? This is the focus. I am being given the directrix, but I don't know the eccentricity. So it is actually essential to be given this extra piece of information here, that the center is 1, 2. Man, kind of added a little bit. Well, if that's the case, then one nice thing is that I can just immediately tell you that C is 2. So that seems like pretty nice, right? Because the distance from the center to the focus is going to be 2. And, well, okay, I'll just tell you right now that if this is the center, if this is the sort of center of symmetry of this entire shape, then it's just got to be an ellipse, right? Because in an ellipse, the directrices are outside the ellipse, whereas in a hyperbola, the directrices are in between the branches of the ellipse. So it's going to turn out that this is going to be an ellipse. What is the sort of way maybe to go about this? I don't know. I'm just making this up as I go along. C is 2. I don't remember ever doing this problem, but I can figure it out. I know everything about conics. What is this distance here? This distance is D. D is the letter we reserve for the distance from the center to the directrix. And, well, if the center is at 1, 2 and the directrix is at x equals 7, it means that, in fact, D is 6. Okay. And I don't know if this is the most efficient way to do this problem, but I just know some things about eccentricity. I know that eccentricity is C over A, and I also know that eccentricity is A over D. These are like the two kind of core formulas, and it's because I can express the eccentricity in these two different ways that I know that C over A equals A over D. And that's how we get to this relationship that CD is A squared. You might have memorized this formula as D is A squared over C, because that's a useful thing to know. But for our purposes right now, I think this is what I want, this right here, because it means I can just calculate A right now. So this is a pretty exciting problem. So CD, C is definitely 2, D is definitely 6. So that means 2 times 6 is A squared, and therefore A squared is 18. And what is A? It's the square root of 18, which is 3 root 2. So that is unexpected. What do I now know? I know A, and I know C, so I can calculate E, the eccentricity. Perhaps we just do that right now. What is the eccentricity? The eccentricity is C over A, and yeah, so that's 2 over 3 root 2, and of course 2 over root 2 is just root 2, so there's actually just root 2 over 3, so that is indeed less than 1. So it really is an ellipse. I was sort of right about that. What does this ellipse look like? Well, A is 3 root 2, so whatever that is, 4 something, right? Because square root of 18 is going to be a little bit more than 4. So that means my ellipse is going to be 1, 2, 3, 4 in a little bit, and 1, 2, 3, 4 and a little bit. And yeah, I guess all I really need to do now is just find B. And for that, I know that in any ellipse, B squared plus C squared equals A squared. And so C squared is 4. A squared is 18. And therefore B squared is 14, and I guess that's all I need to know. So B is like a little bit less than 4. So this ellipse itself is going to be kind of, pretty circular, pretty close to a circle, because A is only a little bit more than B. But anyway, that's pretty much the gist of it all. And I could even do some double checks and stuff, but I think we're just all good. What's the equation? Well, it's an ellipse, it's horizontal, the x-coordinate has been shifted by a factor of 1, the y-coordinate has been, not by a factor of 1, shifted by 1, the y-coordinate has been shifted by 2, and x has been stretched out by a factor of a, which is 3 root 2, so that's 18, b has been stretched out by a factor of root 14, so that's 14. So these are all pretty hard, I guess. Yeah, they're all pretty hard. Interestingly, the next problem is basically the exact same thing. So I get some more practice with this, which is I think good, because maybe I feel like I need more practice with this. All right. So let's go. Part E. Cha. E says we have a conic center at 1, 3, directrix y equals 5, corresponding focus 110. Okay, let's make a picture. So here y equals 5, 3, 4, 5. This is my directrix. Here y equals 5, and let's see. Center 1, 3. So I have a center 1, 3, and corresponding focus at 1, 10. So up here at 1, 10 is my focus. All right. So already I can sort of see what's going on here. This is going to be a hyperbola, because once again, just like before, if this point 1, 3 is the center, it means, well, first of all, if this is the focus and this is the directrix, the conic is going to kind of be, part of it at least, is going to be a curve in between the focus and directrix. But then, if the entire thing is symmetric about this point 1, 3, then that's just one of the two branches of a hyperbola. Or another way of putting it is, yeah, the asymptotes of a hyperbola are sort of in between the foci. And if there's a focus here, in fact, one thing you can immediately sort of do is you can plot the other focus, right? Because if this focus is 7 away from the center, then the other focus is going to be 7 away from the center in the other direction. Ignore those little tick marks there, because they were like bad. 1, 2, 3, 4, 5. Yeah, it's going to be 7 away, so 7 away the other direction. So the other focus will be at like 1, -4. So maybe that is making it, and the other directrix will then be 2 away from the center in the other direction. So the other directrix is going to be here at y equals 1. But I think I don't actually need any of that information to solve the problem. How do I solve this problem? Well, I think I'm going to do the exact same thing as before, right? This little distance here, the distance between the center and the directrix, is d. And this distance between the center and the focus is c. And that's all I need. If I know c and I also know d, then I have everything I need. What is c, as we've been saying? C is 7. What is d? Well, d is just 2. And once again, the eccentricity is c over a, but the eccentricity is also a over d, and therefore c over a equals a over d, and therefore cd equals a squared. Since CD equals a squared, that's exactly the information that I need right now, so that I know that 7 times 2 equals a squared. So here a squared equals 14. And, okay, it's kind of a gross number. Root 14 is going to be a little bit less than 4, I don't know, 3.8 or something. So if it helps you to plot this so you can picture what's going on, A, the distance from the center to a vertex, is going to be a little bit less than 4. So it's 1, 2, up here at 4, whatever. And we're expecting this kind of thing. And then 4 down again, are a little bit less than 4. So the other one is going to be here. Yeah. And it's all making a lot of cents. I'll just write center next to this 1, 3. Okay, what do I need to finish off the problem? I guess I need b. Well, in a hyperbola, a squared plus b squared equals c squared. So if a squared is 14, c is 7, so c squared is 49. So b squared is 35. And I guess that's it. So, what's the equation of this hyperbola? Center at 1, 3, but it is vertical. So y has been shifted by 3. X has been shifted by 1. The y coordinate has been stretched by a factor of a. So that's 14, and the x coordinate has been stretched by a factor of root 35, so that's 35. Man, these are all pretty hard. All right, 3 more to go. 3 more to go. Okay. F. Hyperbola with vertices at 2, 3 and negative 6, 3 and lattice rectum 10 units long. Okay, let's go. 2, 3 and negative 6, 3. 3, 4, 5, 6. So there is 1 point, negative 6, 3. And the other vertex is at 2, 3, so there it is. Okay, these are the vertices. Okay, if these are the vertices, then I can take their midpoint. That will be negative 2, 3. So I already have the center, and I also already know that A is 4, the distance from the center to a vertex. Okay. The lattice rectum is 10 units long. Alright, so how do I recommend... Oh, also it's a hyperbola. Alright, well look, if this is a hyperbola, then I don't really know, maybe, or care exactly what this hyperbola looks like, but I do know it's going to be like this. And I don't know where the focus is exactly, but I do know that when I draw the line through the foci and vertices, that, okay, this picture's looking pretty sloppy. Maybe I should try a little bit harder to make this look more symmetrical. Something like that. Okay, so the lattice rectum is this segment here. And if the lattice rectum is 10 units long, then that means that this little piece of it is 5. And okay, I have now made so many videos. I think I've done this entire derivation, like I don't even know how many times, so I will not do it again. But this length, L, we have proven many, many times that L is b squared over a. And so the definitely simplest way to do this problem is to say that L is b squared over a, but L is also 5, and a is just 4, and so since a is 4, b squared over 4 is 5, and b squared is 20. And that's basically, I'm taking the length of the lattice rectum and exploiting that to, exploiting that sort of formula to find out what A, to find out what B is, since I already know what A is. And once I have A and B, am I just done? I feel like I'm just done. Because the equation then of this hyperbola, well, it's a horizontal hyperbola, centered at negative 2, 3, so it's going to be x plus 2 squared minus y minus 3 squared. X is being stretched out by a factor of A. A is 4, so that's 16. And it's being stretched out in the y direction by a factor of b, and b squared is 20. So that's just the right answer. Okay, good. Let's do one more. Let's do one more. This is kind of an interesting problem. Parabola with focus at -1, 2, and directrix x equals 5. Okay, there are basically two ways to do this problem. Focus at -2, directrix. Okay, so good. So -1, oops, -1, 2 is the focus, and the directrix is x equals 5. 3, 4, 5. Okay, I have found in the past that people, for some reason, they find this kind of hard, even though directrix y equals 5, focus at -1, 2. You basically have two options here. The simplest option imaginable is to not get confused by the 100 things we've learned in the last month, and to actually realize that you've known how to do this problem since December 15th or something. This is just the very, very first thing we learned about the conic sections, which is if you give me the focus and the directrix for a parabola, then what is that parabola going to look like? Well, the vertex will be halfway between, and then it's just going to be a parabola, man. So the gap between the, I guess I can say it like this, that this distance from the vertex to the directrix, and also from the vertex to the focus, because of course those have to be equal, is 3/2, because the focus and directrix are 3 apart from each other, so they're each 1.5 away from the vertex. So, and the letter Q, which I haven't mentioned in a really long time, is the letter which refers to that length. And so one way to do, and then what is that point, therefore? It's -1, it's 2 plus 3/2, so it's just like 7/2, right? Just like 3.5. So that is -1, 7/2 is the vertex, and therefore I just know things. I know that this is a pointing down parabola. So this is going to be x squared equals -4qy is the like general format for it, and therefore the actual answer to this problem sort of must be, because x has been moved by 1, so it's going to be x plus 1 squared equals, when you multiply 3/2 by 4, you get 6. So that's -6, and then y minus 2. Okay, so just like remembering this formula, remembering that that is the correct formula for a parabola centered at the origin, which is pointing down, recognizing that Q is half the distance between the focus and the directrix, finding Q, and then just kind of sticking it all in to the formula is definitely the fastest way to do this problem. There is potentially another way to do this problem, and that is to just like do it kind of from scratch or something, right? So picking an arbitrary point x comma y and just saying, distance to focus over distance to directrix has to be 1, the eccentricity. So nothing's, stopping you from doing this. What do you sort of get? Well, what is the distance from an arbitrary point x comma y to the focus? It's going to be, I'm just now applying the distance formula to x comma y and -1, 2. Well, it's going to be x plus 1 squared plus y minus 2 squared, the square root of that, and that has to equal the distance to the directrix. Well, if the directrix is at y equals 5, then the gap between them, between 5 and an arbitrary y coordinate is just kind of absolute value, y minus 5 is the distance between 5 and x comma y. It's just the difference in those y coordinates. And so an alternative way to do this problem is just to kind of ignore this formula that we memorized a million years ago and just do what we've kind of done recently, which is, just use the definition. that distance to focus over distance to directrix is the eccentricity. It's a parabola, so in this case the eccentricity is 1. So therefore the ratio is 1, and they're just equal to each other. And if I just do out the algebra, I should get this. Let's just do it. I get x plus 1 squared, plus I'm going to multiply that out, so it's y squared minus 4y plus 4. Here I got y squared minus 10y plus 25, and the y squareds cancel, and it's not what I was expecting to happen. 29. Oh, no. 20. Sorry. What happened? Probably was negative 1, 2 in Directrix. Oh! Crap. I see that I completely first of all, I've completely misread the problem. So that's kind of a disaster. But why is this wrong also? This is wrong. Okay, wow. Okay, so I've done bad math and I misread the problem. But of course, it's been shifted by the vertex. So that should be y minus 7/2. Okay, well, it's good that I caught that before the video kept rolling. I wonder how many other errors I've made in this video. Hopefully none. So first of all, if you were freaking out for the past 4 minutes, I'm sorry. This is fixed now. And I am going to just get that, right? Because this becomes x plus 1 squared equals, the y squareds cancel, and I get, adding 4y to both sides gives me 6y, negative 6y plus 21. And when I factor a negative 6 out of 21, I get 21/6, which is 7/2. 42 over 2 is 21. Okay, so the good news is that indeed these are two different ways of solving this problem. The bad news is that I misread the problem, and it's not. Okay, so let's take 1 minute and just do this really fast. It's not y equals 5, it's x equals 5. Oops. Okay, so doing this really fast, the thingy up here is negative 1, 2. The focus, the directrix, 1, 2, 3, 4, 5, is the line x equals 5. Okay, this time let's do it the fast way. Negative 1, 2, so they're 6 apart from each other. So halfway between is going to be 3, which will be at 2, 2. Yup. And that means this is an opening left parabola, which passes through 2, 2. So this now should be easy, because what does an opening left parabola look like? It looks like, y squared equals negative 4qx, and yeah, y's been shifted by 2, and q is 3 in this case, so that's negative 12x minus 2. So that was actually quite simple. Okay, video too long. We make the last one now. We're going to do the last problem, and I think the last problem has like a little hidden fact on it that we've never done before. Although it did come up on your quiz kind of randomly. Parabola opening to the right with lattice rectum, blah, 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 blah. Okay, so maybe this is kind of worth doing. You know, if you give me like a generic parabola, let's just let it be centered at the, let the vertex be the origin, because, you know, why not? Then where will the focus be? Let's let it be Q away. And then let's just talk about the kind of important that I draw the parabola accurately. The focus is going to be, the focus is way out there, then it's going to be quite spread out. Okay, well, whatever. What is the equation of this generic parabola? It is x squared equals 4qy. And a parabola also has a lattice rectum. What is the lattice rectum of the parabola? Well, it's the same as the definitions for the other ones. It's the chord through the focus perpendicular to the axis of the parabola. So it's just that. And if you wanted a general formula for this point, then you could once again maybe call that L or something. What is this point? Well, it's Q comma L. And I can just plug in Q comma L. And what do I get? If I plug in Q for X, because this point has to have the same X coordinate as the focus, then I get Q squared equals 4Q and Y is L. So I cancel the Q's, and that gives me Q equals 4L. Wait, something went wrong. What have I done? It's great. Q comma L. Y is L, 4QL. Q is 4L. That's not what I want to say. X squared equals 4qy. Fact. Oh, that's because this point is not. That's point Q comma 0. That's point Q L. Wait, I'm making some kind of really stupid, horrific mistake, but I can't find it. So embarrassing. What the hell? Q equals 4L? But Q is not 4L. L is 2Q, I thought. Hold on. Give me 1 second to collect my thoughts. It's definitely a parabola. Vertex is at the origin. The focus is Q away from the vertex. So that's Q comma 0. That is indeed the lattice rectum. I go over Q, up L. That's L. That point is Q comma L. The equation is the wrong equation. Oh man. It's a sideways parabola. So it's y squared equals 4qx. There we go. And that was embarrassing. Okay, we push on. Plugging Q comma L into this equation now, I get L squared equals 4Q, and the x coordinate is also Q. Okay, so, good. L squared is 4Q squared, and so L is 2Q. There we go. So what have I just learned? I've just learned something which will look very accurate if you graph it on an accurately drawn parabola, but you know, fact of parabolas, the total length of the lattice rectum is 4Q, 4 times the distance from the vertex to a focus. Okay, let's finish this crap off. So we go and we do this 6, -8, 6, 12. So here's 6, here's -8, and way up here is 12. So that's 6 comma 12, 6 comma -8, and that is the lattice rectum, and it's opening right. Okay, so what that means is kind of an interesting problem. It means that the parabola must be doing some kind of a this, and in fact, let's see, the average of 12 and -8 is 2, so it means that the axis of the parabola is the line y equals 2, because it must pass through the kind of midpoint of this segment, which is 6 comma 2. And, well, what does that tell me, perhaps? It tells me that the coordinates of the vertex, which is maybe the only thing I care about, must be something, so I'll call it x comma 2. And Well, no, let me call it h comma 2, because what is h? H is the x-coordinate of the vertex, but I don't know what it is yet. So one way to go about doing this problem, actually I don't know how you would do this problem without this kind of knowledge that we just learned, but alright, what is this distance? This distance is 10. So if L is 10, then that means that Q is 5. If L is 10, Q is 5. So if I know that Q is 5, I now can tell you where my vertex is, and the answer is it's doesn't quite look like this. It's 5 away from 6 comma 2. In other words, it's at 1 comma 2, my vertex. So the updated, now I have more information, so it's going to be more accurate, answer to this parabola is a kind of does that or something. So this purple one is the right one. It goes through the point 1 comma 2. I know that because Q has to be 5. I know that Q is 5 because the lattice rectum, which has length 20, is always 4 times that length. And I think there are other ways you could have done this problem. But anyway, let's just be done. What do I know about this parabola? I know that the vertex is 1 comma 2. I know it's horizontal. Let me make sure I don't screw this up anymore. So that's y squared equals 4qx is the equation for a horizontal opening right hyperbola. That is a fact. I just learned that q is 5. So what do I get? Y minus 2 squared equals 20x minus 1 is my equation for this. Okay, it's possible that I did all of these problems correctly, though maybe not efficiently. This is a video for you to watch before you hand in the homework of this week, which is the last homework assignment for the semester. Okay, bye everyone.